So we'll start it right from start. It's all about chemical energetics. What we'll see in this chapter is we'll observe chemical reactions, study chemical reactions, and our whole interest will be to understand what is the energy dynamics. Obviously, when a reaction happens, there will be transaction of energy. So our job will be to see what is happening in this energy. Is the reaction eating more energy, giving more energy? How to understand those, how to represent those, and we'll come across many terms. Okay, and this will also be required when you study chemical equilibrium. Knowledge from here will be required, right? And energy in the sense means, like, you'll read about terms like heat of a reaction, what is the heat of the, what is the activation energy. So a broad conceptual clarity is very much required. Easy chapter, nothing more than that. So it says you'll understand differences between physical and chemical changes. The first part will look into that. Then we'll see how physical and chemical changes are exothermic. As of now, don't break your head. What is the exothermic? You might be knowing, but we will do a detailed study. Our study today will be on exothermic, endothermic, so that by the time you leave today's class, you will be absolutely clear exothermic kya hai, endothermic kya hai. Okay? Or when you study about exothermic, endothermic, we'll be studying it from two perspectives. One is physical change mein, what are exothermic, endothermic changes? And when it's a chemical change, it's a chemical reaction. So we'll get into that. Then define exothermic and endothermic in terms of thermal energy transfer. So in a chemical reaction, all that in our head will be chemical energy. Chemical energy is the energy which is stored in the bonds, and those energies will be released, or new bonds will be formed. So those energies will be consumed. But we know that energy can neither be created nor be destroyed. So energy only gets transformed from one form to another. That means those energies are either coming from some energy, if the energy is taken, and if the energy is released, those energy must be changing into some form of energy. So खेल chemical energy का ही है, लेकिन वो जो absorb और छोड़ेगा, that will be in the form of heat energy. ठीक है? And then we will understand something new called reaction pathway diagrams. Today our target will be this. All okay? Set? ठीक है. एक एक चीज को देखेंगे and we will understand. It is written on the board. Listen to me also and keep writing what you feel. I'm not saying I'll give this as a PDF to you, but this is the concise thing. You should understand it first. Let's first discuss about physical and chemical changes. We have been studying about it from 1 or 2 grades below. Physical change. In physical change, there is only a physical change in the form of changes, like ice changing to water. Ice changing to water is water. H2O from solid form has formed H2O in liquid form. And further, if I boil this water, it changes into steam. So that is H2O from liquid form has gone into H2O in gaseous form. H2O overall did not change. That means the chemical identity of the substance is unaltered in a physical change. Have you understood? Take a piece of paper and snip it into many pieces, right? Like you did bad in a test, so you've cut off your test copy into pieces. That's a physical change. अभी भी जो छोटे छोटे टुकड़े हैं वो पेपर ही है, उसकी आइडेंटिटी चेंज नहीं हुई है. So in physical change, what we say, substances remain chemically the same, no new substance is formed. However, make sure that there might be a change in shape, there might be a change in size, there might also be a change of state. State means liquid to solid, solid to liquid. पानी को हमने ठंडा कर दिया, water became what? Ice. Physical change. ठीक है? Physical changes are often easy to reverse. We know that. Ice to water, water to ice. Physical change reversal is very, very easy. And any mixtures produced are usually very easy to separate. Suppose you make a mixture. Sugar dissolved in water. Let us discuss. Aaj Ashmika bola to, sugar dissolved in water. If you want to now separate them, how will you separate?
Sir, you can filter it, but you can boil the water.
Filter? If you filter, how will you get the sugar? You boil the water because water's right. Water, what do you call? Boiling point is much less. Salt and water, if you take, you can actually boil the water. Okay, but if you want to separate out the water, what I'm asking you is that I want to separate out the water, not the salt. Then what do? Salt and water mixed together. See, महात्मा गांधी जी का दांडी यात्रा आपको पता है, उसमें महात्मा गांधी जी ने सॉल्ट को अलग किया था. मैं इस बार कहता हूं कि हमें वाटर को अलग करना है.
Sir,
डिस्टिलेशन. Distillation means when you actually heat, trap the vapor and allow the vapor to condense. So that way also you can separate out. So it means physical change may, we can always change if they are reversible, and physical changes can absorb heat energy. Acha children, as you're writing or something, don't just be a, let's not be only a copycat. What does this mean? Physical changes can involve heat energy. Melting, boiling, vaporization, condensation, all these are classic examples of heat energy. Like when I melt, I am taking in heat. When I'm vaporizing, I'm taking in heat. When I condense, I release heat. When I freeze, I release heat. Clear hua hai? Chaliye. Next we talk about chemical changes. Right. Now this is something where your focus should be more. Let's first discuss what is a chemical change. Typically, a chemical change is a chemical reaction. Why? Okay, then what is a chemical reaction? Chemical reaction एक ऐसा process है where always remember new substances with new properties will be formed. Right? The reacting elements, they lose their identity. For example, as I always say, hydrogen and oxygen, hydrogen being a very explosive gas, oxygen being a supporter of combustion, if they react together chemically, they produce water whose property is that of a fire extinguisher. Then next, let's take a mixture of iron and sulfur in hand, both powders. You mix them and you bring a magnet, the entire iron powder will be sucked out. But if I heat them, they form a black compound called ferrous sulfide. Now you bring the magnet, there is no interaction. And when a chemical reaction takes place, atoms as such do not change. Just think, C plus O2 gives me CO2. Okay, be very ekdam clear raho. C plus O2 gives me CO2. My reaction was with an atom of carbon and a molecule of oxygen. I got a molecule of carbon dioxide. In the molecule of carbon dioxide, what are the constituents? Sir, there is one atom of carbon and two atoms of oxygen. Now they are chemically combined together. Baat samajh mein aa raha hai? Atoms don't change. It's only that the electronic arrangement changes. Have you understood? Right. Only that the electronic arrangement changes. Now, whenever a chemical change takes place, we say a chemical change is not easy to reverse. It does not mean that you can't reverse chemical reactions. We can reverse chemical reactions. In fact, you will read about a chapter called chemical equilibrium, where we will have nitrogen and hydrogen combining together, forming ammonia, where back reaction bhi ho raha hai, ammonia dissociating into. So, but they cannot be reversed by the usual methods of like distillation, evaporation, melting, freezing. ऐसे नहीं change हो सकता है. Are you understanding? You have to spend hell lot of technique to reverse that. Otherwise, just think, every day we are burning butane, LPG, and we are making what? Food. So combustion of any hydrocarbon gives me what? Carbon dioxide and heat. अगर easily reversible होता तो कोई तो सिलेंडर फिर खरीदता ही नहीं ना. वही कार्बन डाइऑक्साइड और हीट को वापस कन्वर्ट करो and water vapor को and make it back to butane. So we say that chemical reactions are not easy to reverse. ऐसा नहीं कि reverse नहीं होते, पर आसानी से reverse नहीं होते, जो physical changes में reverse हो जाता है. ठीक है? और एक बढ़िया चीज, कोई भी chemical reaction होने के लिए energy transaction होना ही पड़ेगा. There has to be an energy transaction. Let us forget this chapter and try to think, why do two things react? Why are you reacting first of all? Because you want stability. And what is your definition of stability? Your energy state. अगर आपका energy ज़्यादा है, if your energy is more, you are highly unstable. Let us put our friend Sasra on the school bus and make the bus move. Her energy, potential energy is much more now. And she will be afraid as the bus moves. And after, say, a 100-meter ride, if you ask her to come inside the bus, she will sit on the floor. This is the best place. I don't want seat also. Because the more less your energy is, the more stable you are. ठीक है? उसी तरह, whenever a reaction takes place, there has to be a transaction of energy. Either you have to gain energy or you have to lose energy, whatever it is. Right? Now you'll think, then to sir, everybody should lose energy. ऐसा नहीं है. There will be some energy which will be taken inside also. Right? Then we say that this energy usually will be in the form of, the book says heat and light. I also say there can be sound also. For example, explosion of a cracker. साउंड एनर्जी, एक क्रैकर को बर्स्ट करने से क्या क्या होता है? हीट, लाइट एंड साउंड, राइट? सो देयर विल बी एनर्जी ट्रांजैक्शन। फिजिकल चेंज में एनर्जी ट्रांजैक्शन होता है, लेकिन एज कंपेयर टू द एनर्जी ट्रांजैक्शन ऑफ केमिकल चेंज, फिजिकल इज एब्सोल्युटली अ किडो स्टफ. See, for example, if you are say melting, let's say if you are melting wax, how much of heat do you want? थोड़ा सा देने से हो जाता है. But when the wax actually burns out to give you light and feeble amount of heat, that energy is much more. समझ में आ रहा है? तो फिजिकल चेंज में जो एनर्जी रहता है वो एनर्जी का ट्रांजैक्शन कम रहता है बेटा. And when it is about the energy in chemical changes, it is much more. Have we understood this much?
Yeah.
Okay, so this portion that we started with, we have understood. I'm just sticking my points. You tell me whether you have understood these 6. यहाँ तक कोई बाकी अभी आप पढ़ो मत. आपको कोई confusion है? Is it legible to you on the what do you call television? It's legible to you, right? 1 minute. एक मिनट अभी तो. There is. Sorry. Ashmita, is it legible? Nidhi, legible?
Yes, sir.
Okay, it's legible. Okay. Yes.
Energy is how is energy like absorbed in form of light?
Energy, light and sound में absorb. Sound में energy absorb कम होता है. With the sound, you don't create a chemical reaction. Light में तो absorb होता है. Photosynthesis. Without sunlight, reaction will not happen. Photography, old age photography. So you have silver bromide. All photo see any sort of decomposition reaction. What is decomposition? Breaking a substance into smaller part. AB will break into A plus B. We can decompose. जब भी आप किसी यूनियन तोड़ रहे हो या किसी चीज को तोड़ रहे हो, आपको इन्वेस्ट करना पड़ेगा ना. So आप जब भी चीज को डिकम्पोज कर रहे हो, then we have to supply energy. Supply it by heat, we call it thermal decomposition. Supply what you call light, we call it photo decomposition, and supply electricity, we call it electrolysis. So energy तो देना पड़ेगा. ठीक है, इतना क्लियर हुआ आपको, right? So then we come down to this takeaway point. Just check this: physical change and chemical change. A change in the physical state of a substance or the physical nature of a situation. Physical nature of a situation. There is a situation whose physical nature has changed. Does not involve a change in the chemical substances present. There is never any change in the chemical. चीज की chemistry change नहीं होती है. And what do you mean by a change in chemistry? Change in chemistry means new substance, new property. Understood? Chemical reaction is a change in which a new substance is formed. This now brings us, since we are in the chapter of energetics, we now need to discuss about that energy. Our everything. All since physical we will not deal about too much. Our dealings will be more with chemical changes, and this is the point on which the chapter will hover now, because your chapter's name is chemical energetics. So you would be talking about the energy transaction. Is it clear so far? Right, good. Now time now to understand two concepts called endothermic and exothermic. Okay, our time now to understand endo and exo. ये फिगर्स पे पहले ध्यान मत दीजिए, पहले चीज को समझिए. Okay, let's understand it from basic. All right, in whether you are actually in physics or chemistry or in engineering, we have a concept of something called universe. Universe is everything that is in and around us. Everything that is in and around us. That is called a universe. And inside the universe, where your concentration or your attention is, or where you are studying it, that is known as system. This is the language of thermodynamics, okay? And anything outside the system is known as surrounding. And together they are known as the universe. This is the concept. System. जिस चीज के ऊपर आपकी एनालिसिस हो रही है, आप पढ़ रहे हो, उसको हम क्या बोलेंगे? सिस्टम. सिस्टम का एक बाउंड्री होता है And that system, later on when you go for higher thermodynamics, you'll study that the system can exchange matter. System can exchange matter with its surroundings. There's a system. My rocket is my system, and it is releasing gases, so it is exchanging matter. As a case, so that what is that type of a wall called? You'll read about adiabatic wall, diathermic wall. Then you'll hear that matter cannot be exchanged, but temperature can be exchanged. A water in a kettle. Water is not going out, but it is exchanging heat. Then there can be isolated system. The best example of an isolated system is a thermos flask. Neither does it exchange any matter outside, nor does it exchange temperature outside. You are able to understand. तो यहाँ इस concept में हमें एक system. तो हमारे लिए system क्या है? The system that we study in chemistry is the test tube, the area in and around the test tube, anything that is there in the test tube, including a thermometer which can be there in the test tube. Please understand concept of system. Like say suppose my refrigerator is now closed. Inside the refrigerator I have got food and other stuff. That is system. Anything outside the refrigerator is surrounding. Now when you talk about chemistry में system को समझना थोड़ा सा complex हो जाता है. Chemistry में the test tube in which the reaction is happening is a system. Not only the test tube, the region around the test tube is also the system. What is inside the test tube, that particular reactants and products what you have, is also system. And if you are putting a thermometer inside the test tube to measure, then the thermometer is also a part of the system. इतना याद रखिएगा, ठीक है? Easy example से देखेंगे. If you have a process, and from here you pay attention. If you have a process in which heat is written as Q, heat is going inside the system, right? Heat is going inside the system. Then what will happen to the surrounding? The surrounding will cool down, obviously, and the system should little bit heat up. System should heat up. Now I'm talking in terms of physics, okay? But there'll be another picture which I'll show. At that time you will have little bit of controversy with me, but don't worry. Now you absorb like that. If the system takes in heat, we are not worried about chemistry now. If a system takes in heat, then the system's temperature is supposed to go up and the outside temperature is supposed to fall. Have you understood? Such a process, such a process is known as a endothermic process. Biology में हम endo पढ़ते हैं ना, endo exo. Endo मतलब अंदर की तरफ. जब system के अंदर के तरफ heat आ रहा है, it is known as an endothermic process. Have you understood what is an endothermic process? An endothermic process is a process, endo, andar ghusna. Endothermic process is a process where a system absorbs heat. However, remember, the total energy of this universe is always constant. You can't create energy, you can't make energy. या बाकी diagrams मत देखो, आप सिर्फ इसको देखो अभी. You can't create energy, you can't destroy energy. So if your energy has gone up, someone's energy must go down. Surrounding का energy नीचे चला गया. और अगर हम इस वक्त इस energy को only thermal energy consider कर रहे हैं, thermal energy's measurement is through the temperature. A body who has more thermal energy is supposed to be at a higher temperature. Yeah, I have absorbed heat inside, so my temperature goes up as a system. Surroundings temperature goes down. Very easy concept. Is there any sort of ambiguity on this understanding? Have you understood endothermic? Let us see some everyday thing. Melting of, now we'll marry it little bit with chemistry. Melting of ice. Melting of ice happens only when ice takes in heat, right? So if I have a test tube and I put a block of ice inside it, right? Here we are saying system gets heated up. However, the region around the test tube will cool down. क्योंकि ice melt कहाँ से हो रहा है, उसको heat कहाँ से मिल रहा है, आजू बाजू का. Today our friend Dhruv always used to bring cold water to my classes, and he used to keep that bottle out here. What used to happen? Water droplet used to form outside the table. Was your bottle leaking? No, your bottle is cold, so your bottle is now absorbing heat from the surrounding. As a result, it has started to cool the heat in and around the bottle, cool the air in and around the bottle. So the air around the bottle has condensed, leaving droplets. Have you understood this? Take a glass of water from the refrigerator and keep it outside. You see droplets on the outside of the bottle. फ्रिज का एक बोतल निकाल के बाहर रखो, थोड़ी देर बाद पूरा गीला हो जाता है. ये पानी कहां से आया? Where does this water come from? That bottle is so cold, and the environment today is at, say, Hyderabad, something around, say, 35, 40 in summers. So 40 degrees, say, heat is going inside the bottle, right? So 40, the surrounding is losing heat. So the immediate periphery of the bottle, the air has condensed, and that is forming bubbles. So in your book, you will be seeing diagrams where they will say that in the endothermic process, cold लिखा रहेगा. Cold माने आप खाली ये मत समझो कि the ice, because I told you in chemistry, system is the test tube where the ice is kept. What is inside the test tube? What is in and around the test tube itself, and the thermometer inside the test tube. The thermometer's temperature नीचे आ जाएगा. समझ में आ रहा है? And it needs heat. Thermometer तो पहले temperature up down ही नहीं होगा, because melting is a constant temperature process. In melting, all the heat goes and hides inside, latent heat of fusion. It's a constant temperature. Melting में कभी भी temperature rise नहीं हो सकता है. Look at the cooling curve. In melting, it will always be straight. After you have become 100% liquid, then only the curve rises, the temperature rises. Have you understood? So let's suppose somebody says melting of glacier. Is it an endothermic process or an exothermic process? We say melting of glacier is an endothermic process. Unless the sun shines, unless the glacier takes in heat inside, how do I melt? So if glacier is the system, heat came from the surrounding. Evaporation, endothermic process. Whenever there will be evaporation, area will cool. बारिश के बाद देखिए ठंडा हो जाएगा. Or else the matka concept, you know how people keep the matka cold. So a matka is an earthen pot. The earthen pot has lot of pores in it, which allow water to go in and out. What we'll do on a hot summer day? On a hot summer day, we will take a cloth, and that cloth will be a gunny or something like a sack. We will dip it in cold water, and we will wrap it around what? That particular pot. Slowly, you will find that the gunny is drying out. उसका हीट कौन सोक कर रहा है? मैम सोक कर रहा है, वाटर ले रहा है, तो वो वाटर कूलिंग में आना शुरू हो जाता है. Have you understood? Evaporation is also an endothermic process. Unless you give the heat, evaporate कैसे होगा? And evaporation is only a surface phenomenon. Boiling is a convection phenomenon. So is endothermic clear? Okay. Our next process is to understand what is an exothermic process. A process in which system releases heat to the surrounding. System is giving heat to the surrounding. So if the system gives heat to the surrounding, now you yourself say the surrounding should heat up, obviously, and system should cool down. That's the process. For example, let's say we are burning coal. Burning of coal is actually my system. And the heat, coal will be generating lot of heat. That's an exothermic process. All combustion, respiration is a slow, what do you call, exothermic process. It's a slow combustion. All combustion processes are known as exothermic process. In this world, you have more of exothermics and less of endothermic. ये true or false पूछा तो याद रखिएगा. Endothermic reactions do happen. Children, we need to understand it in two concepts. First is changes. Physical change, chemical change. So in a physical change, if somebody tells you, tell me an exothermic physical change, exothermic physical change. Tell me an exothermic, okay, tell me an endothermic physical change. An endothermic physical change, very easy. Boiling, melting of ice. Endothermic physical change, melting of ice. Right. Now, when we talk about chemical changes, means about chemical reaction. Our chapter will be more about chemical reaction itself. And in chemical reactions, the exothermic reactions are more common than endothermic. Reactions give out energy. Obviously, everyone would like to reduce their state of energy. There are certain reactions where they are endothermic, जहां ज्यादा एनर्जी पहले लेता है. ऐसा क्यों होता है वो भी देखेंगे. पर आप physics, from the perspective of thermal physics, have you understood what is an exothermic process? An exo an exothermic process. Exo, this is endo. And the best way to remember them is heat enters, enter, endo. Heat exists, exist, exo. So now let's look at our diagram. Abhi diagram dekh. Now our diagram says that if you have an exothermic process, okay, if I have an exothermic process, this is an exothermic process where heat is released, a reaction that releases energy from the system in the form of heat. Burning of any fuel, all the natural gases that you are burning or LPG that you are burning, what is your system? System is LPG. वो आपको heat दे रहा है, heat बाहर जा रहा है. So sometimes there are two things. Now let's see who will answer me. Is cooking endothermic or exothermic? Cooking is endothermic, but the fuel burning is exothermic. Cooking is endo because potato, paneer, meat will never tenderize unless and until they take in heat. So cooking is endothermic. Clear? यहाँ पे और कोई doubt है? No doubt. So remember, there are many more what you call exothermic reactions than there are endothermic reactions. Are we clear? If you have a reaction in which the heat is released from the system to the surrounding, in such a case we say that we have actually what? A exothermic reaction. In an exothermic reaction, surrounding temperature will go up because after all the law of conservation of energy tells us that energy can neither be created nor be destroyed. Total energy of the universe remains constant. Universe comprises of two parts. ये book में नहीं रहेगा. ये जानना जरूरी है. Physics में आपको help करेगा. Higher classes. Universe has two parts: system, surrounding. Whatever you are studying or is your point of interest is system. Anything apart from that is surrounding. My refrigerator is my system. Everything in and around the refrigerator is surrounding. And together in and around, even America is also a surrounding for my refrigerator. And everything together with my refrigerator is the universe. चले next slide. यहाँ पे सकते हैं. अब ये diagram आपको contest करेगा. Like we used to say ना. So we will now get around this diagram a little bit. Hold on. Let's see. Surroundings include, as I said, in chemistry, the reaction mixture in the test tube, the air around the test tube, that is the surrounding around the test tube itself, and the thermometer inside the test tube. When you are analyzing it from the perspective of chemistry, there is a chemical reaction that is happening. In order for that chemical reaction to happen, there has to be certain reactants and there has to be certain product. Please don't confuse your system to be the reactants. The chemical reaction is the system. उस reaction को होने के लिए आपको reactants चाहिए. So let's see this diagram. Okay, that will give you. Now, exothermic will not be an issue. Exothermic gives out energy. Agreed? If it is giving out energy, don't you think that your system should cool down? That's why I said the diagram that I drew was from the perspective of physics, which also applies in thermal chemistry also. But you will say, sir, I burnt a piece of coal. Is it exothermic? Obviously, coal gives a lot of heat. But you said then coal, sir, should give lot of heat. Surroundings should heat up, which I do feel, and coal's temperature should come down. ना. तो तुम थोड़ी coal को पकड़ लोगे. Coal is also a part of the surrounding only. The reaction of combustion is the system that we are studying. We can't show you कि coal जाने के बाद क्या हुआ. इसलिए थोड़ी देर बाद आगे जाके हमें और clearly see. I can't try and show you when coal is getting reacted. Imagine a system where coal's reaction is happening. You don't try to focus about hot coal. You see that there was carbon. Carbon actually underwent combustion. So system was carbon. And the reactant sides had more heat with it. From there, they are able to give out the heat to the surroundings. Are you understanding? In any exothermic process, the reactants will, आपको ये heat मिला कहाँ से? See, end of the day, our perspective is the chemical energy of the system. Chemical energy of the system means whenever you say system, the reaction as a whole. The chemical energy overall the energy of the reactants and products do vary, but the overall energy cannot vary. Na? I had so much of chemical energy. After you burnt me, my chemical energy has come down. So where did your other energy go? In the form of heat. When we try to see it from the perspective of chemistry, if I tell you that this is system, then this should cool down. Yes or no? Means this is the chota burning coke or the coal. Can you touch that? That means no, you can't touch that. So the coke which you see is also a part of, because transformation has happened. Na? You started with carbon. Carbon transformed into कार्बन डाइऑक्साइड, ऐश में ट्रांसफॉर्म हो गया है आपका. ये सिस्टम नहीं है. सिस्टम इज द रिएक्शन. This is still a part of the surrounding now. Therefore, in chemistry, we say the surrounding is the test tube, air around the test tube, what is inside the test tube, as well as the thermometer that is in the test tube, and that's the most important part. That's where you are getting confused. इसको कैसे सिस्टम, ये तो ठंडा हो जाना चाहिए ना, धीरे धीरे होता है ना. System means if you, this test tube is your observation. When you see it as an observation process, then the test tube's temperature will be very high. Exothermic reaction है तो आप कैसे feel करोगे? The energy change in the system is what you are worried about. You are concentrating on what is happening to that carbon that I brought. Our reaction is not like that. See, what you are trying to understand from physics is correct, that if I show you a refrigerator as a system, what is a refrigerator? It's a system. Everything outside is surrounding. What is the refrigerator doing? Exothermic process. Cooling मतलब बाहर heat फेंक रहा है. उसको समझना easy है. इसको जब आप समझोगे तो आप रिएक्शन कहां कर रहे हो? एक टेस्ट ट्यूब में ही तो रिएक्शन करोगे ना. तो अगर टेम्परेचर बढ़ा तो कहां बढ़ेगा? टेस्ट ट्यूब गर्म हो जाएगा ना. You have not gone to lab, otherwise let me tell you, ammonium chloride, let's say ammonium chloride. Ammonium chloride is a substance जिसको आप बकेट में डालते ही बकेट freezing cold हो जाता है. In our hostel days, when we used to win matches and say suppose you need cold drinks and other stuff, refrigerator तो होता नहीं था. Get the expired ammonium chloride from lab and put it in bucket and put all your thumbs up and everything, freezing cold, immediately it will become cold. Have you taken tuna, calcium carbonate, the tuna that we get, limestone, calcium carbonate, put it in water, bubbling will happen. It's an exothermic reaction. अगर हम वैसे देखें, then you should say, sir, calcium carbonate should actually radiate heat outside and it should cool down. Anything that is heating or cooling is a part of the surrounding, and you will always be in chemistry, you will get to know it from the surrounding only. System को तो आपने physically देखा ही नहीं है. So my question is now, I have a test tube. Let's go to the ammonium chloride experiment, and I put ammonium chloride in it, and I'm telling you this is an endothermic process. Ammonium chloride in water is an endothermic process. Take it for granted. That means what? Surrounding temperature should cool down, system temperature should go up. So you expect that टेस्ट ट्यूब के अंदर क्या हो जाना चाहिए? गर्माहट पैदा होना चाहिए और बाहर ठंडा होना चाहिए. वही ना? तुमको क्या अंडरस्टैंडिंग इश्यू है क्या? यू पे अटेंशन टू व्हाट आई एम सेइंग ना. एवरीथिंग आई से ही स्टार्ट्स लुकिंग. Ammonium chloride in water is an endothermic process. So you take a test tube and you put ammonium chloride in it, in water. Understood? It's an endothermic process. Physics says surrounding should cool and system should heat. If you think that what is inside is system, then I should not have put my Coca-Cola bottles inside that bucket. All the Coca-Cola should have heated up. All Coca-Cola gets cooled down. That means that is also a part of the surrounding in chemistry. Does that make sense now? Our thermometer cannot measure the system. Our thermometer can only measure the surrounding. We get to know whether the reaction is endothermic or exothermic based on the surrounding temperature. And in chemistry lab, the test tube is a surrounding. The test tube body is a surrounding. The air around the test tube is a surrounding. Inside the test tube is a surrounding. The thermometer inside the test tube is also a surrounding. System is the reaction that is taking place. You can't go and conceptualize the system. You can conceptualize the system only in physics. वो refrigerator system है.
Okay.
You sleeping in an AC environment, your room is the system. ये केमिस्ट्री में ऐसा नहीं है. केमिस्ट्री में आप कैसे सेंस करोगे? वो तो रिएक्शन के अंदर सिस्टम है. The reaction itself is you have a system out there. That's the transaction of energy is being seen there. Clear? So let's see here. Exothermic gives out heat. This warms the reaction mixture and heat is given out. This warms the reaction mixture. Please understand. The reaction mixture is a component of the surrounding. Whatever you took, if that substance got heated up, now let's ask you as an ATP question. I took something in a test tube heated up. Exothermic or endothermic? Exothermic. Inside the test tube, heat must have generated inside the test tube ना, तभी तो test tube गर्म होता है रे भाई. ठीक है? Now let's see endothermic process. Endothermic process में कैसा रहेगा? सब कुछ ठंडा हो जाएगा. The reaction mixture, ammonium chloride and water, will cool down. There will be bubbling around, droplets will form around this test tube. और हाथ लगाने से भी ठंडा लगेगा. उसमें थर्मोमीटर डालूंगा तो उसका टेम्परेचर भी नीचे आएगा. यही मुझे बताएगा कि ये एंडोथर्मिक प्रोसेस है. ये सिस्टम नहीं है. द रिएक्शन मिक्सचर इज द सराउंडिंग. प्लीज अंडरस्टैंड.
Sir,
यस सर.
question.
श्योर.
Sir, when it is surrounding around the test tube, that won't change, right, sir?
That means you are not going to around the test tube means a very narrow region around the test tube बेटा.
Okay.
अब जैसे ये कूलिंग होगा ना, तो ये एरिया में भी कूलिंग का एहसास तो हो ही जाएगा. इसीलिए तो यहाँ ड्रॉपलेट्स फॉर्म होना शुरू होगा.
Okay, sir.
अगर लेकिन आप अगर यहाँ बैठे हैं ना and you are thinking that I want comfort today and I'll put ammonium chloride and I'll sit here and I'll feel cold. नहीं, ये भी होएगा. ये कैसे होएगा? फिर इस साइड में आपको एक छोटा सा फैन ब्लो करना पड़ेगा. फिजिक्स सीखो ना, और वो आपको कोल्ड एयर यहाँ पे ब्लो करेगा. यही तो कूलर का काम है. एसी का काम भी तो यही है. इन एसी व्हाट इज हैपनिंग? इन एसी यू हैव अ रेफ्रिजरेंट व्हिच इमीडिएटली कूल्स डाउन. Right? It cools down. It will take all your heat and then when you compress it, it cools down. The compressor runs. The cold AC refrigerant will come inside your internal unit of your house in what we call as expander. And that cold is immediately dissipated by a fan blower. That's why when the compressor knocks off and you say, AC thanda nahi kar raha hai, khali garam hawa chhod raha hai, that's the fan air that's coming to you. Right?
Yes.
And again, once it takes away the room heat, the AC refrigerant again becomes liquid. ये फिर जाके चला जाएगा, आपकी गैस बन जाता है. Sorry, it becomes gas. It's a gas. It becomes gas. It goes inside into your compressor. The compressor will again pump it. As it pumps, इसको compress करके liquid कर देगा. Again, the liquid comes into those tubes. The
Yes.
small tubes which are there, it will come. Take away the heat, go back. ठीक है इसका. ठीक है.
Yes, sir.
So have you understood how to, in chemistry, how will you understand whether your system is actually, and what is system बोल रहा हूँ, your chemical reaction or the reaction process is endothermic or exothermic? Sir, for endothermic or exothermic, we will always see the temperature of the reaction mixture. If after the reaction mixture is cooling down, then it is known as a endothermic process. If after the reaction mixture has got heated up, कोल को हमने गर्म किया तो कोल में हाथ थोड़ी लगा पाओगे, और गर्म हो जाएगा. Then it is known as an exothermic process. But do not confuse it. An exothermic is a process which gives out heat from the system. यहाँ system is not the reaction mixture. The bond breaking जो है ना, वहां पे system है. वो आपको pathway से समझ में आएगा. इतना clear हुआ? So the surroundings will include the reaction mixture in the test tube. The final important point is, it is the thermal energy transferred to the thermometer that causes the rise in the temperature or the dip in the temperature. Exothermic means heat exists. Endo means heat enters. The reaction. This is more important. Now we will see. अच्छा देखो, ये ऐसे ही आपको बता सकता हूं. Let's take carbon. Sorry. Let's take a piece of coal. Carbon plus oxygen gives you what? Carbon dioxide. Don't you think you get a lot of heat from this? Obviously. Exothermic means heat exits the reaction. Photosynthesis. In photosynthesis, what are the raw materials? Carbon dioxide and water. Sunlight, energy enters the reaction, gives you what? Glucose and oxygen. Okay? Kirtan darling, are you understanding?
Yes.
All right. Sorry. What happened? Okay. Fine. Shall we go one step more? Okay. So this is your summary. Endothermic reaction, heat is absorbed by the system, physics perspective. Temperature of the surrounding is decreased, because we will learn this in physics also. We have to understand that. Favored by a high temperature surrounding. Favored by a high temperature surrounding. Let us interpret this in terms of chemistry. Heat is absorbed by the reaction mixture. Heat is absorbed by the system. So temperature of the surrounding, that is the reaction mixture, will cool in this case, and favored by a high temperature of the surrounding. This is endothermic reaction. Favored by a high temperature surrounding means endothermic reactions will happen only when the surrounding temperature is more. Then only there will be a heat gradient. Favored by. Do you understand the meaning of the third line? Favored by. ये समझ में आ रहा है? पहले फिजिक्स की नजर से देखो. Heat is absorbed by the system. Temperature of the surrounding is decreased. In the terms of chemistry, heat is absorbed by the reaction. Heat is entering the reaction, and temperature of surrounding means temperature of reaction mixture is decreased. The third line says favored by a high temperature surrounding. आपको सिस्टम में हीट घुसाना है. That means surroundings temperature must be more. Then only the heat will flow this way. Otherwise, heat will not flow. So it's favored by a high temperature surrounding. ये इतना जरूरी नहीं है जो green में है. This is from physics perspective. Don't break your head on that. We'll break our head on this one. Now see, exothermic reaction. Heat is released by the system. In our case, children, in our case, the system is always the chemical reaction. Please remember that. And the surrounding is always the reaction mixture. Is this thing clear? दोनों के लिए ही होता है. Heat is released by the system. Heat is released by the reaction. As I showed you, C plus O2, CO2, heat is released. Temperature of the surrounding is increased. Temperature of the reaction mixture. कोयला जो हाथ से लाके रखा था, अब जल चुका है, अब उसमें हाथ नहीं रख सकता हूं. क्लियर हुआ? उस कोयला को तुम सिस्टम मत मान लेना. Okay. Some examples they may ask you. This thing, make a note of it. Chemical changes, condensation and freezing are exothermic changes. These are, sorry, chemical changes I'm saying. Physical changes. Very rare if somebody asks you, give some examples of endothermic and exothermic. Endothermic and exothermic physical changes. Physical. Endo, melting and vaporization. Exo, freezing and condensation. इसको ये तो हम भी जानते हैं. Now come to chemical reactions. Now these reactions are a part of your, I'll tell you which ones are a part of your syllabus. Okay. ये forest fire, dissolving magnesium chloride in water, adding zinc हो गया है. ये zinc है actually. 1 minute. Okay. This will be zinc. Adding zinc to copper to sulfate. You should remember these reactions. ये रहेगा आपका, थोड़ा देर बाद हम इन्हें देखेंगे. Adding zinc to copper sulfate. Make a note of these three. So exothermic, combustion, all combustion. Digestion. Is digestion exothermic? Yes, digestion happens with respiration only. So respiration is exothermic. Forest fires are exothermic. These are from physics perspective. समझ में आ गया. But in chemistry, if somebody tells me, tell me an exothermic reaction, if they don't specify, then the best is you should always say carbon burns in oxygen. Okay. Also remember one thing, though this will be helpful in other chapters, all hydrocarbons, or fuels, whenever they react with oxygen, they'll give you CO2 plus H2O. This H2O is water vapor actually, huh? Plus heat. This is always a, what do you call, this is always a exothermic reaction. Have you understood this one? All hydrocarbons, methane, ethane, propane, acetylene. Okay. So a best example is carbon burning. Okay, next let's see some endothermic reactions. Photosynthesis. Then this one, nitrogen and oxygen reacts to form nitrogen monoxide. This example comes in Cambridge books a lot. Why? Because there are two times this reaction will happen. Make a note of it. First, listen, nitrogen and oxygen reacting together to form nitrogen monoxide. One, this will be seen in engine chambers of automobile. In your syllabus, it is mentioned. Another, in the atmosphere, these two gases also react. That reaction happens during lightning's time. Because you need what? Energy. What will give you energy? देख ध्रुव, ये दोनों रिएक्शन, ये जब भी मिक्स होते हैं तो आपको क्या देगा? नाइट्रोजन मोनोऑक्साइड. इसको हमने किसके अंडर टर्म किया है? एंडोथर्मिक. आपको एनर्जी चाहिए, एटमॉस्फेयर में रोज एनर्जी है, लेकिन कुछ और चाहिए. लाइटनिंग के टाइम पे ये होता है. एंड इंजन चैम्बर में भी ये रिएक्शन होता है क्योंकि वहां भी टेम्परेचर बहुत ज्यादा रहता है. नाउ डू यू अंडरस्टैंड? एंडोथर्मिक इज फेवर्ड बाय अ हाई टेम्परेचर सराउंडिंग. डू गेट द ट्रिक नाउ? एनी एंडोथर्मिक होने के लिए भाई साहब कोई ना कोई तो आना पड़ेगा ना. सम सांता क्लॉज हैज टू कम टू यू विद लॉट्स ऑफ एनर्जी. सो नाइट्रोजन फॉर्मिंग नाइट्रोजन मोनोऑक्साइड inside the engine chamber, it gets heat from the burning of the fuel, and during lightning it gets the heat in the atmosphere to actually become nitrogen monoxide, supporting an endothermic process. Have we understood this? And finally, you should ask, sir, all this heat energy that coal is releasing, coal is getting this heat energy from where? It is the chemical energy, is the energy released or absorbed. If you are supplying energy for certain reaction, then also this lightning energy, means light energy, is getting converted to chemical energy. And if a fuel is giving you a lot of heat to cook your food, the heat is coming from the chemical energy of the fuel. Now later we will study, not in today's class, that how do fuels give you heat? Bonds break hota hai, bonds form hota hai, तो उसमें भी heat का transaction होता है. बोलिए सर, इस स्लाइड में अश्मिता, हैव अ लुक. व्हाट आई एम ट्राइंग टू से हियर इज examples of endo and exo based on physical change. This is examples of endo and exo based on chemical reactions. What are the two reactions? Magnesium chloride in water adding zinc to copper. Suddenly a question will come where zinc को copper में add करके आपको दिखाएगा. And they will tell you, since this is exothermic, the test tube warmed up. When zinc was added to a blue salt solution, the test tube warmed up. Identify the process. Identify the blue solution. Copper sulfate, and the process is exothermic. चले आगे. One more topic only today. ऐसे पढ़ने से हमें याद रहेगा. यहाँ पे कॉन्सेप्ट क्लियर होना बहुत जरूरी है. Fine, bacha. Please note down. Later I'll give you a PPT, but I'll not tell that. I should not. लेकिन PPT अगर दे दूं ना तो आपको दूंगा मैं, ऐसा नहीं दूंगा. किनेस्थेटिक्स होने से जब आप लिख के पढ़ते हैं ना तो आपको याद होता है. ऐसे PPT लेने से आपको मजा नहीं आएगा. You share this with some friend of yours. If that talk and that note is not there, you don't interpret it. It's just like a book. Even rusting is exothermic. Rusting is slow combustion. Reaction with oxygen. Paka? Chale aage? Okay, next one. Now, next is the last part of today, which is we have to study about reaction pathway diagram. Do not concentrate on the figures now. Now just try to listen. What is a reaction pathway diagram? Where are we now? Now we are at a stage where we know that whenever a chemical reaction is happening, there is a transaction of energy. Bhai sahab, ya to energy andar le raha hai. Kaun? System. That is the chemical reaction. It is either taking energy, in that case we will call it endothermic, or the chemical reaction is giving out energy. Taking in means it will be always in the reactant side. Taking out means it will be always, given out means it will be always in the product side. So our question comes is, so from this we get to know that it will be either an exothermic process or an endothermic process. Now, how do you indicate exo and endo? By a energy pathway diagram. Whenever we construct an energy pathway diagram, it's very simple. It's an x and y axis diagram. On the y axis, that is, the energy of the reactants and products are on the y axis. Reactants and products. Let's see this. Let's pick up one reaction. We have in our book, the reaction is all about methane. Okay, a little bit of talk about methane. Again, it will be married with your hydrocarbon chapter organic. Methane is the major constituent of natural gas. What we are cooking here is liquefied petroleum gas, LPG. Our major constituent is butane, not methane. But if you go to Delhi, or if you go to some parts, even in Hyderabad, like Bhagyanagar gas, or you go to places like Mumbai, where they have got pipe connection, MGL, Mahanagar gas, that is natural gas, PNG, pipe natural gas. Their main constituent is methane. Our constituent is butane. Butane's calorific value is little bit more. मतलब एक ही सॉसपेन में एक ही सोर्स से पानी लेके दिल्ली के घर में हीट करना और हमारे घर में हीट करने से हमारे यहाँ जल्दी बॉयल होना चाहिए, प्रोवाइडेड प्रेशर इज सेम, बिकॉज आवर कैलोरिफिक वैल्यू इज मोर. Anyway, it is a fuel, CH4. So this is the striking reaction for any hydrocarbon. Do you remember the days when we were learning chemical reaction balancing? I used to actually give you octane, propane, कुछ भी है ना वो यही रिएक्ट करेगा, reacts with oxygen to give you carbon dioxide and water vapor. This water vapor, actually, if your reaction is not happening, if your combustion is not complete or incomplete, then have you seen in villages, vessel काला गिर जाता है. The carbon mixes with this only. और यही आपको काला गिरा देता है. ठीक है? Now let's see. Now this reaction we know is an exothermic reaction. Why? Combustion reaction. It's a fuel. So exothermic means heat exits the system. Heat has to exist the chemical reaction, not system, chemical reaction. Our chemical reaction, this chemical reaction is the entire system. ये मान के चलो अभी. Surrounding क्या है? The reaction mixture. Okay. So in the pathway diagram, on the vertical axis, we will show energy. Energy in kilojoules. Whose energy? Reactants and products. It is an energy axis. And on the right side, what we show? Progress of reaction. That is time, basically. As the reaction is progressing, what is the change in energy? So this sort of reaction we say is an exothermic reaction. That means the system has given out heat. How much heat did the system give up? We said overall, देखो हमेशा कैसा रहता है? Overall we know energy can neither be created nor be destroyed. This is something like the overall content, है ना? Now if you see, the reactants had an energy. Reactants are what? The green bar. The reactants had an energy at this point. Sorry. The reactants had an energy which was given by this point. And after the reaction, उनका energy कितना हो गया है? इतना हो गया है. Chemical energy down हो गया है. Stable हुआ? हुआ. Chemical energy सब गया कहाँ? Heat होके निकल गया. कितना heat निकला? इतना heat निकला. This was the total heat of the reactants. This is the heat of the products. This much is what you are getting out from the system. Understood?
Yeah.
So a reaction pathway diagram, the reaction pathway or the progress of the reaction is on the horizontal axis with the reactants on the left and the products on the right. There is a small little black arrow. This black arrow's direction will actually tell you whether it is exo or endo. अगर exo है तो heat बाहर आ रहा है ना. So it says the energy indicated by an arrow upward or downward between the reactants and products. In this case, the energy, what do you see the arrow direction? Arrow direction is there. So energy यहाँ से जाके energy down हुआ तो बाकी heat निकला है. So for an exothermic reaction, this is important. You see that the energy of the reactants is higher than the energy of the products. Obviously, energy of the reactants. नहीं तो heat देगा कहाँ से? And the black arrow points downwards to show that energy is released. Energy releases. What is our system? The entire reaction is our system. अभी clear हुआ? Chemistry के नजरिए से देखें तो क्या है? Physics के नजरिए से देखना easy रहता है. Chemistry के नजरिए से ये पूरा the whole reaction. So this is the example of exo. एक endo का example देख लें. वही nitrogen वाला. Let's see the nitrogen. Reaction between nitrogen and oxygen is endothermic. It is one of the reaction that takes place in the hot engine when the fuel is burnt and also takes place in the atmosphere when there is a lightning. Because for an endothermic reaction to happen, there should be favorable hot surroundings, है ना? So nitrogen plus oxygen gives you carbon monoxide. इसमें कैसा रहना चाहिए? Heat enters the system. मतलब ये reaction जब शुरू हो रहा है, at that time the energy of the reactants is less. Heat is entering the system. So arrow is upwards and now yeah. So if you see the overall energy of the product is high, but the overall energy of the reactant was less. Where did the product get this energy from? Well, this is the heat जो जाके ultimately clear हुआ. So it says for an endothermic reaction, you can see that the energy of the reactant is lower than the energy of the product. The black arrow points upwards, which shows that the energy is absorbed or taken in. By whom? The chemical reaction. So, before we conclude, 2-3 questions. What do you understand by a surrounding in a chemical reaction? The reaction mixture, the test tube body, the air around the test tube, and the thermometer dipped inside the test tube. They are not my system because our common concept is system वही है शायद. No, system is the chemical reaction. ठीक है? And if we are doing an endothermic process, surrounding cools, air around the test tube cools, thermometer inside the test tube cools, reaction mixture inside the test tube cools, test tube body also cools. And if we are having an exothermic reaction, surrounding heats, air around the surrounding heats, thermometer inside the test tube shows a rise in temperature, reaction mixture heats, and the test tube body also heats. So what all did we learn today? Physical and chemical changes. Number one, a few examples in which we understood in physical changes, there can be heat absorption or heat rejection. Okay? Physical changes are usually reversible. Chemical changes cannot be reversed. Chemical reactions will always show some large amount of heat transaction. Usually the number of exothermic reactions are more than the number of endothermic reaction. Then we got a fair bit of ideas what is endo-exo. Endo enters, exo exits. थोड़ी देर बाद आप पढ़ेंगे mexobendo. Breaking of bonds endothermic, making of bonds exothermic. Mexobendo also we will hear, but in the next class, not now. Then we understood how to represent the heat of the transaction of energy through a reaction path, energy pathway diagram. An energy pathway diagram is a diagram which shows the energy transaction that is happening during the process of a chemical reaction. On the y-axis, the energy of the reactant and product is taken, and on the x-axis, the reaction, the course, the progress of the reaction. What we show here is that if you are an exothermic reaction, then heat leaves the reaction. Arrow comes downwards, the heat of the reactants is more than the heat of the products. And if you are an endothermic reaction, heat enters the system, arrow's direction is on top, the heat of the reactant is less, the heat of the product is more. समझ में आया? And some examples like magnesium chloride dissolved in water, exothermic, zinc dissolved in copper sulfate, exothermic, nitrogen, oxygen forming natural. And all fuels, any fuel which is burning is always exothermic. That concludes our class for today. And this one, whatever was there, I will be uploading it as a PDF. Also check your textbook, also nothing will be left up. But this is the crux. इसको अगर आपने अच्छे से पढ़ लिया, and there are some textbook questions. I mean, those are much more easy. I mean, hardly. We should look at more of the exam question. Textbook questions are absolutely like, they'll tell you, tell me whether cooking is endothermic or exothermic. I think those are pretty fine. Understood? बस ऐसा ही चाहिए. 1 घंटा पढ़ो, मन लगा के पढ़ो. I'm sending this as a PPT now. Righto, we meet on Monday at 9 o'clock. Have your Monday morning will be difficult. So on Sunday night, keep your, I'm upfront telling you, ruler, protractor, compass, pencil, and a graph book.